into the logistic growth, which is what we're going to do tomorrow. Instead of me just like jumping in and going over it, I want you to kind of try these two first. So on Friday, what we looked at was just like the general stuff. So we looked at the types of proportionality. We looked at translating it from an equation and then solving it. And then we did two examples. We did the bacteria one, which was the special case. It was the special case because we had the dy dx that is equal to ky. That's the one shortcut we can always take. That's going to be your exponential growth or decay model. And then we did the loudness one dealing with decibels. The one I want to start on today is the balloon one and then the apple one. Before I go over it though, I do just want to give you a chance to try them first. So for each of them, you're going to match it to the correct slope field and then write the differential equation and solve it. Again, to be quite honest, I typically see mistakes in this topic not on the calculus, but on like the algebra. So like solving for the missing two constants and things like that. So go ahead and try those two for me. Then we'll go over them. I'll talk about our plans for the remainder of the week, and then basically whatever we have remaining with class, you can use that to work on homework or look over your quizzes that I'll pass out to those of you here in person after we go over these notes. But go ahead and try the balloon one and the apple one. Again, if you want to ask questions while you're working on it, feel free to do so. But I'll give you about two problems. I'll give you about, how long do I think you need? We'll say 15 minutes at least to try those problems, then we'll see where we're at. And then I will say, for those of you who are returning to Roswell next year, so basically everyone who's not a senior, feel free to let me know if you have any questions on your schedule for next year or anything like that, especially if you are thinking about applying to the Georgia Tech math. That's mainly going to be something you work with on your counselor to make sure you get all the paperwork turned in for that. But do definitely let me know if you have any questions. You can do that, of course, now, later, or email them to me. I'll do my best to answer them. But I'll be quiet for a bit unless you're asking me questions. Let me try those two on your own.
Check out your search pen.
Oh, that's pretty good. I'm not going to give it. Oh my gosh, no way. If you want to, but I'm going to pull out some teeth.
My masks have to stay on.
What do you mean? What do you
You
mean?
might have like a shake or something you pull out.
No, yeah.
I have a pencil. This
Well,
one's
I never bring a shank to school. You're like giving your mic away.
I was looking it up on Korea's yesterday when I walked by it.
Do you see how bad it looks right now? It's
It's
broken.
not terrible. We just have a wreck in it, that's all.
Yeah. It's like driver's seat to drive around. People like look.
It still drives.
You should have put a note on it.
I'll do it next time.
nice one. Right on the den.
Good job.
I am a smooth move, buddy.
Was it me?
And again, for all these types of problems, you will always have two initial conditions because you're always going to have two constants. So that being said, when you are integrating, don't forget that plus c, or you will, of course, be wrong. But again, I typically see more mistakes not in the calculus for these problems, but in the algebra. be about 2 more minutes and then we'll talk about these two problems. All right, so one of the things that we had looked at on Friday was when given a problem situation, we were at least able to kind of identify the slope field. Which again, a slope field shows like all the different possible general solutions to a situation. So for this balloon one, we see that this balloon is being inflated. So clearly we should be looking for a slope field that is increasing. So hopefully you did eliminate C and D pretty easily. Between A and B, which one's going to be the best choice for that slope field? A. So we did use B for the exponential one already on Friday, but B is definitely much steeper, while A is going to be much more direct. So the answer for that slope field you should have gotten was A. The next part is, of course, solving the equation. I do find that sometimes students do mess up when solving this particular problem, so you do want to pay attention to what your variables are representing. It tells you that the value y is representing the balloon's diameter. So y is representing the diameter. And it says that y changes at a rate that is inversely proportional to the square of the diameter. And again, the diameter is y. Keyword that we see when something is inversely proportional is always going to end up in the denominator. So I have dy dx is equal to k. That's our constant of proportionality over y squared. And then separate and integrate. Do you want to talk about my two answers I kind of have in red of when you separate and integrate? So yes, y squared does become 1/3 of y cubed. And then the other side, k is a constant. So we have kx plus c. Make sure you definitely don't forget that plus c. That's a very common kind of simple mistake. You can use that to kind of solve the constants, which is what I did. That's what you see kind of in the black handwriting. Or do you realize that any equivalent way you rewrite it also works? So honestly, this one probably would have made more sense if I solved it by multiplying everything by 3 first. When I multiply by 3, I no longer have a fraction to deal with. And then you have 3 times k. K is a constant, so 3 times k is just another constant. I called it d. And then 3 times c. C is a constant, so 3 times c is also a constant. So I just made up another letter and called it e. So to be honest, this last one is definitely probably the easier one to solve, but just to kind of show you that it doesn't matter which one you solve for, I'm going to solve it for that first one. Again, for most of these, we will have to have, not for most, for all of them, we will have to have an initial condition for 2 different instances of time, because we do have 2 constants defined. So I plug those in, and we'll always have a systems of equations. You can solve it by substitution. I prefer elimination because it tends to be pretty direct when you are solving it by elimination. So subtracting one from the other, that's going to give me negative 56 over 3 is equal to negative 7k. The c's are canceling out after you subtract. Dividing by 7, we get k is equal to, what's that, 8/3. And then once you know what your k is, you can plug that k into either equation to find your c. I'm definitely going to plug it into the simpler one, so I'm going to plug it into that top equation. This one is unique because yes, you would need to have that plus c as part of your work, but we do see that c would be equal to 0. So writing that final equation, we had, what was it, 1/3 of y cubed is equal to kx plus c, which is, of course, the c is 0. Solving this one for y, so it's a little bit easier to deal with. We have y cubed is, I don't want to put k there, that should be an x. Let me try that again. 8/3 of x. So y cubed is 8x. Our y is equal to the cube root of 8x. Questions on that problem? Yes, Seth?
Could you solve for, if you solve for y,
Mhm.
before plug anything in, would that just make the algebra a bit more difficult?
Yeah, you wouldn't be able to do eliminations. Like if you solved it for y, like you would have just this answer or something like that. And you wouldn't really be able to do any elimination with that. So if you are gonna like do anything, or at least isolate just the y cube, but don't go much further, then you're just gonna have to undo it when you start solving for it. Any other questions on that first one? All right, and then I tried to just pull like a variety of like follow-up questions, just making sure we kind of knew how to answer these different types of questions. Most of the time you're going to ask yourself, like, are you going to plug something into y or dy dx, or are you going to set y or dy dx equal to something and solve? So the ones I chose for this one, I have, what is the balloon's diameter at x is equal to 15? Well, if I'm looking for the diameter, I would be plugging it into just y, which we just saw that was the cube root of 8x. So what is the diameter? The cube root of 8 times 15. What will be the units that we're just talking about the diameter? Meters, pretty easy. And that will be the answer to that first one, pretty straightforward. This second one might require a little bit more work to kind of figure out. It says, at what rate is the balloon's diameter changing when x is equal to 15? So if I want to talk about at what rate the balloon's diameter is changing, what am I going to be plugging that into? dy dx, and again, we already wrote that equation. dy dx was k over y squared. Well, we did find k already. K was that 8/3. We are plugging in 15, but that's the x value. So we do need to plug that into the y value squared. What was the y value? The cube root of 8x. So kind of like an ugly dy dx once you plug everything in. And then we just want to find the rate of change when x is 15. So I'm just going to kind of redo my fractions. They look a little bit nicer. I have 8/3 times 1 over 8 times 15 to the 2/3, or any equivalent answer like that. If this is the rate of change of the diameter, it would be meters, and my unit of time was minutes. So it would be meters per a minute. Questions on those two problems? All right, finishing this up then. Then we had the apple one. So we have the apple falling. After 2 seconds, the object is at 8 meters, and then after 7 seconds, its height was at 2 meters. Which slope field did you say was the best match for that one? Say it again. C. C is definitely knew it was decreasing, and you just wanted to find the one that matched those points. We can kind of easily check. We have 2, 8, and then 7, 2. That one's definitely going to work. The other one is going to flatten out a little bit too much. Since solving the apple one, I did go ahead and kind of do my work a little bit for this one just to kind of discuss it. In green, you see my setup for the derivative. So it says that the rate of change of y, dy dx, is directly proportional to x. When we see directly proportional, that means we're going to be multiplying it by that constant of proportionality. So that's where the kx came from. Integrating both sides, didn't really worry about separating this one because there was no y's. But that is going to give you k over 2 x squared, and then of course don't forget your plus c. Again, you could solve either equation. Like if you want to use y is equal to k over 2x squared plus c, you could. Or if you want to make your algebra a little bit easier to deal with, k is a constant. So what is k over 2? Just another constant, so I just picked another letter and broke that down instead. I'm going to use the rewritten one just so I can avoid dealing with fractions, well, until I get to my answer when I'm solving for this one. So I have my two initial conditions. That's what I see in red. And then to solve it, we are going to solve it by elimination. And so I get that d is equal to that fraction, -6 over 45. And then once I know d, which if you had solved it for k, then you would plug it into for k, use that to find your c. So I did get c was equal to 8 plus 24 over 45. Final answer, I used the rewritten version, so it would have the height y is equal to d x squared plus, and then I had my c value. I do like, again, if you ever solve it, you can always go back and easily check your slope field. So if I'm looking at this y, it is a quadratic, but it has a negative leading coefficient, so it's going to be a downward facing parabola. And if I go back and look at c, we can see that that c does look like a downward facing parabola. Now we're just looking at like the right hand side of it, but you can see that it would be a downward facing parabola if you kind of extended that graph. So it is nice to be able to check that slope field after you solve it. Any questions on my solved differential equation? All right, and then for my follow-up question, again, I'm just trying to think of the different variety ones I could ask. When will the apple hit the ground? What is that basically asking you to find? When y is equal to 0. So you basically just set y is equal to 0 and solve. So I have 0 is equal to, and I already forgot what it was. That. I'm gonna be lazy and copy it. And then just set that equal to 0 to solve. This is a quadratic, so technically there would be a plus or minus for this one when you solve, but we are talking about time, so we're not really going to have a negative time for this problem. So solving it, I'm going to have this negative, subtracting the c value from both sides, times the reciprocal of that slope, and then take the square root of that. And that would be in seconds. Again, if you don't like the ugly answer, you could, of course, simplify. And don't be stressed out, that would be a positive number that you're taking the square root of. You do have like that double negative going on. And then this last one, it says, what is the apple's speed at the moment when it hits the ground? What would be your basic process for solving that one? So we're looking for the speed. Which equation are we plugging that into? dy dx, right? So we have dy dx. It was equal to kx, and so I can go ahead and plug everything in. K was that -6 over 45. When it hits the ground, that's going to be the x value you find from the first one. And that would be your answer. It does say speed, so we would want to remind ourselves that speed is the absolute value of velocity. And that's important to remember, because if I'm looking at this answer, I can see that dy dx would be negative But if I were to answer this question, I would want to make sure I just gave a positive answer. Again, speed in calculus is going to be referring to a positive value. Questions on those last two problems? All right, so to finish up, this was the unit that we were talking about, kind of differential equations and proportionality. The one problem I do want to go back to, just to remind yourselves of something, and that is going to be the one with bacteria 2. There's one shortcut we know for now, and that is for a very specific type of differential equation. And if you haven't already memorized it, I do just want to kind of emphasize it. That is the differential equation dy dx is equal to k times y. So not dy dx is equal to k times x, but dy dx is equal to ky. If you ever see that differential equation, you know automatically this is going to be an exponential growth or decay problem. And instead of having to separate your variables and integrate, please, please, please just automatically jump to this form, your basic exponential growth or decay model. It saves you a bunch of time, and it also helps you answer questions. If you have dy dx is equal to ky, you know it's going to be an exponential. I emphasize that to you right now because tomorrow we are going to learn another memorized differential equation pattern, and that's going to be our logistic growth model. And that's what we're going to look at tomorrow. That will be the last day of notes for this unit. Wednesday and Thursday will be review days, completing your briefcase binder and all that. And then coming up quickly will be your Unit 9 test on Friday. So things that I want you working on, and of course I am here to answer all of your questions as they kind of come up. So that's the homework I assigned on Friday, that homework number 4. And that's what I would hope that you can kind of finish. If you do finish that today and you want to go ahead and kind of keep working to get ahead, you can also go ahead and work on your briefcase binder. Those of you here in person with me, I am about to give you your quiz for you to look over. And then basically we're just going to be getting ready for our test on Friday. Only one more official homework this week, and that's going to be the one that has the logistic growth equations. I do have a few like optional and extra practices in OneNote. But mainly that's where the last homework will be, and then the test is going to be on Friday. Any questions about what I want you working on for today?